Renowned professor Dr. Michio Kaku said that we may need to rewrite our textbooks.
All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Something is wrong. We may have to revise our theory of the creation of the universe.
Astrophysicists are questioning everything they thought they knew about the universe. But how does it come to this? It's because of a galaxy called GZ9P3. This NASA discovery came from the James Webb Space Telescope, the most powerful eye ever built for astronomy. And what James Webb found is shaking the very foundation of science itself. It was a faint speck of light, but it turned out to be one of the oldest, largest, and most developed galaxies ever seen. If what we are seeing is real, then the Big Bang story we've been telling might need a serious rewrite. But let's dive deeper to actually see how we found GZ9P3 and how it is challenging science itself. Years ago, the Hubble Space Telescope captured what looked like tiny smudges, nothing unusual because there are countless tiny smudges across the cosmos. Astronomers flagged it for follow-up. Then, the James Webb Space Telescope observed it, and it turned out to be a galaxy. This galaxy, GZ9P3, was only 510 million light-years after the Big Bang. Think about that. The universe today is 13.8 billion years old. Back then, it was less than 4% of its current age. And yet, somehow, GZ9P3 had already formed billions of stars, becoming one of the most extreme discoveries in modern astronomy. Scientists were stunned. One called it finding a skyscraper in a village of tents. Another said it was like a baby running a marathon before learning to crawl. Here's why this is so shocking. Our best cosmological model, known as lambda CDM, predicts that galaxies should form slowly after the Big Bang. In the beginning, the universe was basically just hydrogen and helium. Over time, gravity pulled gases together into small clumps, sparking the star formation that lit up the first galaxies. This process was supposed to be gradual, tiny galaxies merging over billions of years to form larger ones. But GZ9P3 throws that idea out the window. Just half a billion years after the Big Bang, here it is, a galaxy 10 times more massive than its neighbors, already filled with billions of stars. It's like opening a history book about early humans and finding skyscrapers, highways, and smartphones in the Stone Age. This isn't just a small inconsistency. It's a cosmic red flag that something about our models might be wrong. So how did GZ9P3 manage to grow so quickly? The James Webb Telescope revealed some important clues. When astronomers looked closely, they noticed a double nucleus. This suggests GZ9P3 wasn't just one galaxy. It was two galaxies in the middle of a merger. Mergers are like rocket fuel for star formation. When galaxies collide, gas gets funneled inwards, triggering massive bursts of star birth and rapid growth. In cosmic terms, it is an accelerant, a catalyst so to speak, that can turn two small galaxies into one giant in record time. Webb's telescope instruments also detected heavy elements like carbon, silicon, and iron. These elements are only created in stars, then spread by supernova explosions. That means GZ9P3 had already gone through multiple generations of stars, enriching its gas with metals long before theory said it should. This galaxy wasn't a newborn. It was already chemically mature, sort of a teenager surrounded by cosmic infants. But how does GZ9P3 challenges us? The existence of this galaxy challenges several pillars of modern astronomy. First, it suggests that star formation was happening much faster and more efficiently than we believed possible. Galaxies weren't supposed to be able to create so many stars so soon. Second, it suggests that galaxy growth was rapid, chaotic, and merger-driven, not slow and steady. And third, it puts pressure on the lambda CDM model, which has been our go-to explanation for decades. If GZ9P3 is just the first of many galaxies the Webb telescope finds, then we may need a new framework altogether. This just isn't a tweak. It could be a cosmic paradigm shift, a rewrite of science we've trusted since the discovery of Big Bang itself. The scientific community is buzzing. Some are calling this a NASA discovery of historic proportions, proof that the early universe was far more dynamic than we imagined. For them, GZ9p3 is a thrilling glimpse into the unexpected. Others remain cautious. Measuring galaxies this far away is tough. Dust, black holes, and overlapping lights can sometimes make a galaxy appear older or larger than it is. A few researchers argue that maybe GZ9p3 isn't as massive as it seems, or maybe it is just an outlier. But here's the kicker: GZ9p3 isn't alone. Webb has already spotted other early galaxies, like Jade's GS Z14O and Glass Z12, that look way too big and bright for their age. So, whether this is a one off fluke or beginning of a pattern, one thing is undeniable: the James Webb Telescope has opened a new chapter in cosmic discovery. But the question is, why should we care? Well, the story of galaxies is also the story of us. The heavy elements forged in galaxies like GZ9p3, carbon, oxygen, iron, are the same elements that make up our bodies, our planets, our entire world. If galaxies like this were already producing those ingredients so early, that means universe may have been ready for complexity and maybe even life much sooner than we thought. This discovery isn't just about rewriting science textbooks, it's about rewriting our origin story. It's about understanding how the building blocks of everything we know came to exist. The James Webb Telescope has only started its mission, and it's already challenging decades of assumptions. As it continues to scan the skies, we'll likely uncover even older galaxies, stranger structures, and maybe even the seeds of the very first black holes. And Webb won't be working alone. Instruments like the Roman Space Telescope will push deeper into space, testing whether galaxies like GZ9p3 were rare outliers or whether the universe was teeming with them. If that's the case, then the early universe was not a quiet, slow dawn. It was a raging storm of growth and star formation, writing a story we're only just beginning to read. Thanks to the James Webb Space Telescope, we're discovering that the early chapters of universe's story doesn't look the way we thought. They're stranger, faster, and far more incredible. GZ9p3 just looked like a speck from our telescope. I wonder how many other specks we are missing. Do you? Let me know what you think in the comments. And as always, thanks for watching.